degrees. So again, in the same way, it will just be 3 pi by 4 times 180 divided by pi. And so we can simplify this. We are going to get 4 and then 5. So this will just be 3 times 45. What is 3 times 45? Quickly, what is 3 times 45? That's a simple arithmetic. $135. I hope that is true. Right, so this is how you just convert from one to the other. Is there any question? So actually any degree, for instance, if you have 30 degrees, then you want to convert to radians, then it is just 30 times the pi over 180, and that gives you pi by 6. Okay, so that should be easy for everyone to do. Right. Now we want to move to what are known as the trigonometric ratios. So again, I want to erase whatever is here so that we can use the same board. So we have what are known as trigonometric ratios.
Hi, team.
Right, so the trigonometric ratios, you have also seen them, you have known them, you know how to manipulate them. So these are ratios that you get on a right-angled triangle. So they are ratios of a right-angled triangle. So let's consider the right-angled triangle, which I will draw as follows. I hope my drawing is okay. It's not very nice. Right, so let's consider the right-angled triangle. Let that side be A, this side be B, and that one be C, and then that angle be theta. So we know the following ratios. So we start with what are known as the primary ratios. So the primary ratios are the following. The first is the sine ratio. So we have the sine ratio, which is given as follows. So sine theta, all of you know that this is the opposite over the hypotenuse. Right, so that's the sine ratio. And of course, the opposite of this angle theta here is A, and the hypotenuse in this case will be C. So this is the first trigonometric ratio, which is called the primary ratio. The second, of course, is the cosine of theta, which is the adjacent divided by hypotenuse, and the adjacent in this case will be B divided by C. So that is the second primary ratio. And the third primary ratio is just the tangent of theta. The tangent of theta is opposite over adjacent. So in this case, the opposite over the adjacent to the angle is just A divided by B. Right, so these are what are known as the primary ratios. And of course, you also know that tan theta is just sine theta divided by the cosine of theta. And of course, you have sine theta as A divided by C.
Yeah, if the number of people that are on Zoom is very low, maybe we should join Google Meet.
Yeah, but I'm using Zoom to record also because I can't record on Google Meet. So that's why I said at the beginning, if the numbers are going to be this low, then we would rather go with the Zoom throughout and record. Okay, so people on Zoom, please welcome. Let's continue from where we stopped. Let me just share with you the screen. I hope you can, those on Google Meet can still see the screen. All right. So I was saying that the tangent of theta is the same as you may know that it is sine theta divided by the cosine of theta. And we found sine theta to be A over C, and the cosine is B over C. Get my pen. Right, so in that case then, you can see that what we have now is what we found to be A over B. Because when you do the mathematics there, you find that C cancels and you remain with the A over B. Okay. So I said that these are called primary ratios. Definitely you must have some secondary ratios. So let's think of secondary ratios. Let me use another board. Okay. So for the secondary ratios, you have met them also. And these are the trigonometric ratios of course of a right angled triangle, which are, in this case, they are reciprocals. Reciprocals of the primary ratios. So the secondary ratios are just reciprocals of the primary ratios. And these are the following. So the first you have is what is known as the secante. So I'll write the term in full, the secante ratio. So this ratio is given as sec theta is equal to hypotenuse divided by opposite. So, adjacent, not opposite. So the secante is the hypotenuse divided by adjacent. So if we recall our triangle, this is just C over A. Let me put the triangle here again. So that was our triangle. We have theta, we had A, B, and C. So this is a right angle triangle. Right, so that is the second, the secondary ratio, which is the first. But then you also know from what you have done before that the sec of theta, or the secante of theta, is just 1 over the cosine of theta. So that is the reciprocal of the cosine. Samuel, you have your hand up. Ah, yes, thank you. That's B. Okay. Right, so sec theta is just 1 over the cosine of theta. And of course, 1 over the cosine of theta, we remember that the cosine of theta is the adjacent over hypotenuse. So in this case, you have 1 divided by the cosine of theta, which is B over C. Right, so this is what we get as C over A. Okay, so that is the first secondary ratio. The secondary ratio is called the cosecant. So the cosecant ratio is defined as follows. So it is the cosec of theta, and this is equal to hypotenuse divided by opposite. So this then is just the C over A. Right, so this is the second trigonometric ratio, which is secondary in this case. If you have something to say, please, you can go ahead. I said on the Google Meet, I can't see the hands, but all right, I can hear some sound.
So, on the second ratio, I'm seeing C over A. Where is the A coming from? Whereby in the actual sense, we have B over C.
Okay, my mind is, I guess, thinking of A. Right, so it is C over B. Thank you for that correction. Right, so you have this as C over A. By the way, the other notation that is used is the cosec of theta. So whether I write this or this, it means the same. Right, but also we know that this cosec of theta is just 1 over sine theta. So this is what we have, which is just 1 over A divided by C, and that's what gives us C over A. Right, so that is the cosecant of theta, which is the secondary ratio. We have also the third secondary ratio. I'm trying to move my board down, but it is not moving. Oh, okay, it has reached its end. Ah. Yes, that's 1 over sine theta. Okay, so we can move to the third ratio. So let me clear this first. Okay. Right, so the third ratio, of course, you know it. The third ratio is the cotangent. So the cotangent, as the name tells you, is the reciprocal of the tangent. So that's a cotangent ratio. And is defined as follows. So you have cot theta is equal to adjacent over opposite. So adjacent over opposite, if we can still remember our triangle, this is going to be equal to B over A. But we also note that the cotangent of theta is the same as 1 over the tangent of theta. So it's the reciprocal of the tangent, and we found the tangent to be A over B, so that is what will give us B over A. Right, so those are the secondary ratios that we get for trigonometric functions. And these, of course, you have met them before, and you have worked with them. I guess there shouldn't be any problem or challenge with working with them again. Right. So next we want to look at what are known as standard trigonometric ratios. That is the standard trigonometric ratios that are interesting to us. So standard trig ratios. First of all, let's consider the Cartesian plane. So we have the Cartesian plane. The Cartesian plane is divided into 4 quadrants. So we have the first quadrant here. Then the second quadrant is in this place. You have the third quadrant here, and the fourth quadrant. So when we consider angles, we'll be checking in which quadrant this particular angle is. So that's what we will be doing, and that will help us to get the trigonometric ratio that we are interested in. Right, so let's start with the standard ratios. And the standard ratios we'll look at are those for the angles 30, 45, 60, and the others. Okay. So let's consider the following. So let's consider an angle which is in the first quadrant. And let's call this angle theta. So you have an angle theta. So consider that. We are interested in the angles. So 30 degrees is in the first quadrant. So you know that angles are measured in rather anti-clockwise. So all the angles 30, 60 are in the first quadrant. Even 45 is also in the first quadrant. So for us to be able to get the angles, so I was just saying 30, 45 in terms of degrees, and the 60 degrees are all angles in the first quadrant.
Guys, what's up, guys?
You can mute your mics, please. Yeah, so that's the challenge of online learning with the unstable networks that we have. For some reason, I don't know, was thrown out. Right, so let me just share the screen again. Meet and Zoom. Okay, so just confirm that you can see the screens, because my network can disappoint me again. Great. Right, so let's continue and see how far we can go today. So I was saying that we can look at standard angles. So I call them standard angles. So I have standard angles of 30, 45, and 60 degrees. So I was saying that these are all in the first quadrant. But then we'll start with the standard ratios of 30 and 60 degrees. So let's consider an equilateral triangle. So let me try to draw an equilateral triangle. I hope it will look better. So we have an equilateral triangle, call that A, that edge B, and that one C. So if it is an equilateral triangle, let it have side equal to 2. So you know that in an equilateral triangle, the angles are all equal to 60 degrees. So you have 60 degrees as your angles. But then what I'm going to do is to write or draw a perpendicular to BC. And then we are going to bisect the 60-degree angle into those two angles of 30 degrees. Right, so if we bisect this, then we said that the side is 2, so it means that we are cutting that line BC into two parts which are equal. Now, we have also looked at what is known as Pythagoras theorem. So by Pythagoras theorem, we have the following. So we want to find the side. Let me call this point here P. So we want to find the side AP. We know the length of the other sides. So we are just going to find the length of AP using Pythagoras theorem. So we have two triangles here, which are each of them right angled. So in this case, what we are going to do is to use Pythagoras theorem. So Pythagoras theorem says the following. So AC squared is equal to AP squared plus PC squared. So that's what we have from Pythagoras theorem. And so this now AC, we know what it is. It is equal to 2. So you have 2 squared is equal to, so this implies that 2 squared is equal to AP squared. That's what we are interested in. And then PC is given as 1. So that will be 1 squared. So this implies that AP or squared should be equal to 4 minus 1. And so in this case, AP, which is our length we are interested in, is just the square root of 3. Right, so this is what we get when we consider this particular triangle. So now, we want to get the standard ratios. That's what I said. So let me write the standard ratios on this part of the board so that I can still use the diagram. So we have sine 30 degrees. So sine 30 degrees from the diagram here, if you use any of these two right-angled triangles, it is given as the opposite over hypotenuse, and then you can see that this is equal to 1 over 2. So that is the first standard ratio. The second is, of course, the cosine of 30 degrees. Again, any of these right-angled triangle, you can see that what you are going to get, because we found this as root 3, so we are going to get root 3 over 2. So that is the cosine. And of course, the tangent of 30 degrees is just the opposite over the adjacent, which is 1 over root 3. So that's what we have from the triangle that we have written. Secondly, we can think of the sine of 60 degrees. So you see, again, from the triangle, using any of these two, sine 60 is opposite over hypotenuse, which is the square root of 3 over 2. Wait. Okay. So that is the sine 60. So you can see from here the opposite is root 3 and the hypotenuse is 2. And then also we have the cosine of 60 degrees. So the cosine of 60 degrees is 1 over 2. So that gives you 1 over 2. And then the tangent of 60 degrees will be equal to, again, any of those triangles. If you look at it, it will just give you one, or rather opposite over adjacent, which is just root 3 over 1, which will just be root 3. So those are the standard angles or standard ratios that we are going to be using in all that we do. So your duty is for you to be able to know these ratios and use them appropriately. Is there any question so far? Right, so if there is no question, of course, you have done SADS, so you can rationalize, because we don't usually want to leave SADS in the denominator. So that would be root 3 over 3. And of course, whenever you have SADS, you can always rationalize. Okay, so I do not have, I have only 3 minutes on Zoom. So the next thing I want us to do is to look at the standard angle 45. So I'll just ask for a few more minutes for me to be able to do that, and then we can call it a day. Is there any question? So Zoom people still use the same link? Okay, so if there's no question, let me just restart the meeting on Zoom, and then we can proceed. Oh, apparently I was not recording. That seems so sad. But the numbers that I'm seeing here tells me that there is no need to use saying that we use the Moodle for recording, and we can use the Google Meet for attending. But of course, you're able to see what's going on and you're able to follow. Right, so I said we just talked about the standard ratios of 60 degrees and 30 degrees. So we want to look at the standard ratios of 45 degrees. So I'll clear this screen, and then we see how we can get the standard ratios for 45 degrees. So if you can't see the screen, say so. Or if there is any challenge, please let me know. Right, so standard ratios for 45 degrees. So we are going to consider the following. So again, we will start with a triangle. So this triangle is an isosceles triangle. So earlier we considered an equilateral triangle, but now we will consider an isosceles triangle. So an isosceles triangle, of course, you know that it has the two sides equal and the two angles equal. So let me draw the triangle. I hope I can draw it nicely. I can see if I can draw it using that thing. Okay. So I was saying that this is a right angle triangle, and it is an isosceles triangle. So two sides are equal. So we have that side and that side to be equal. And then we have the hypotenuse in that particular situation. So let's call this triangle with the following letters. So here we have A, there we have B, and here we have C. So we have 45 degrees, and that one is also 45 degrees. So again, we will bisect. So we want to bisect this angle here. So we bisect it, we cut it into two and draw a perpendicular to that line there. So this is a 90-degree angle, and that's a 90-degree angle. Again, let's call this point P. So here, our sides, the hypotenuse will have length 2, so that will be 1 there, and that one will be 1. So if it has the length 2 units, then it means that when we bisect this angle here, that side also will have 1. So this side AP is equal to 1 also. and then degrees, and that's 45 degrees. So you see now we have two isosceles triangles in this isosceles triangle that we have. So by Pythagoras theorem again, we can see that the length AC, I'll just write it as the square root of PC squared plus, so that's PC, then AP. So by Pythagoras theorem, that's what we have. So that gives us the square root of 2, which is 1 squared plus 1 squared. So in that case, we have that this is root 2, and also similarly, that one is root 2. Right, so with this, then we can get the standard angles, or the standard ratios for the angle 45. And in this case, we have that the sine of 45 degrees, you can use any of these triangles that we have for us to be able to find the ratio. So we can see that sine is the opposite over hypotenuse. So in this case, you have 1 over the square root of 2. Of course, we can write this as root 2 over 2. And then the cosine of 45 degrees, I've forgotten to record again.
Recording in progress.
So the cosine of 45 degrees, again, you can see from any of the triangles that this is going to be equal to 1 over root 2, which is the same as the root 2 over 2. And the tangent of 45 degrees, again, this is just going to be so opposite over adjacent. So in this case, you're just going to get 1. Right, so these are the standard ratios that we have for sine, the cosine, and the tangent of 45 degrees. Is there any question or any clarification that one wants to make? So rationalize. That's what I said. You rationalize the denominator. Do you know how to rationalize the denominator? Yes, because we did that. Not so.
Yes, sir.
Do you want me to remind you?
No.
Okay. It's good if it is okay. Any other question or clarification?
Sir, how is tan 45 equal to 1? I didn't see clearly how you did it there.
Maybe I've made a mistake. Let's see the triangle. So if you are using that triangle and you have 45 as your angle, the tangent is the opposite over adjacent, isn't it? So the opposite of this angle is 1. The adjacent of that angle is 1. So it is 1 over 1, which is 1. If you are here, you still get the same. It is the opposite, which is 1, and the adjacent to it is also 1. Is that okay?
Yes, sir,
But
it is now.
again, if you want to use sine over cosine, you can see that you are just dividing 1 over root 2 divided by 1 over root 2, which is 1.
I've understood clear, sir.
Okay, so any other question? I want to give you one more thing.
So, sir, these ratios that we are finding, are they the primary standard ratios?
Because it's the same ratios now, you just find the reciprocals. So the reciprocals, you should be able to get them. All right, so let's now see just one more thing for today. We want to consider the sign. Are people in Google Meet with us? Okay, I'm seeing something going on my computer. All right, so we want to think of sine 0 degrees, the cosine of 0 degrees, and the tangent of 0 degrees. Right, so in this case, let's think of a circle. Let me see if I can draw a circle again. Right, so we have a circle, and let this circle be on the Cartesian plane. Okay, so that is on the Cartesian plane. This circle is of radius equal to 1. So it is a unit circle. So let's consider this unit circle, and then think of any angle. Let me call this P. So we have that angle theta. And then at P here, let me change the position of P. It is very far from what I want to illustrate. So P is here. And then let's draw a perpendicular to the x-axis from P to the x-axis. So this is a perpendicular. I'm using paint shop, which is not. not very friendly to use sometimes. Right, so we have a perpendicular and we have our angle here. Let's call this angle theta. Now, if we have a point P, Q, let me call this point here M, and that is the origin. So now, you see the following as you are looking at the right-angled triangle, which is the OPM. So using the right-angled triangle OPM, we have the following. Sin theta is equal to opposite, which is PM, divided by the hypotenuse, which is OP. So that's what we have. And the cosine of theta is equal to adjacent, which is OM, divided by the hypotenuse, which is OP, and the tangent of theta is the PM divided by OM. Yeah, so these are the ratios from what we have. Now, let's try to do the following. So first of all, let me call this point here R. So let's see what happens as we consider the following. So, my mouse is running away. Right, so consider P approaching R. So imagine yourself, you are moving from the point P and you are coming to R. There are some changes that take place. The first change is going to tend to 0. So theta will be tending to 0 as you approach P, or rather R from P. And the second thing that you are going to see is that the length OM, will be approaching 1. So as you are moving along the circumference of the circle, you see that theta is changing and it will tend to 0 when you reach R. And also OM will move to R. So M is going to move to R and the length is going to be equal to 1. So in this case then, what we see is the following, that sine theta, or rather sine 0, as you approach 0, sine 0 will be equal to, we said PM, but then PM has tended to 0, as you can see in that case. So that will be 0 over, and then OP is going to be equal to 1 because P will be now on R. So you get 0 over 1. And so sine 0 is equal to 0. Again, if you consider the cosine of 0, the cosine of 0 is adjacent over hypotenuse. So the hypotenuse will be equal to 1 as P will be on R. And the adjacent also is going to be equal to 1 because M will also be on R. So in this case, you see that the cosine of 0 will be 1 over 1, which is equal to 1. And then the tangent of 0, in this case, we are saying that the OP is 1, or rather, PM is 0, and the OM is equal to 1. So in this case, you are just going to have 0 divided by 1, which is equal to 0. So those are the ratios when you look at the 0 degrees. Is there any question on this one? Yes, please. Okay. I take note of that. Any other? Okay, so you have a few minutes before the class. Let me just tell you something about the angle 90 degrees, and then we can stop there. So I want to still use the same diagram that I've written here. So I'll erase some of the things that we have. Right, so again, those ratios are still the way they are. We'll leave them as they are. Now we want to consider 90 degrees. So what we observe, what we notice is the following. So let's approach Q. So P approach the point Q. If P approaches Q, it moves on the sec, of course, along the circumference. What we see is that theta is going to be approaching 90 degrees. So you are going this way now. So you see that as you move P along the circumference, you come to P, to Q, the angle there is going to be 90 degrees. And then, of course, the length, PM. So PM, you see that here, as you are moving, M is also moving towards the origin. So once you are in that place, it means that PM is going to be equal to 1. So this will approach 1. So in this case, we have that sine 90 degrees is the opposite over the hypotenuse, and you can see that PM becomes 1 and the OP becomes 1. So this gives us that ratio. The second ratio is the cosine of 90 degrees. The cosine of 90 degrees, you look at OM. OM becomes 0 because, of course, M is moving to O. So this will approach 0. So in that case, you have 0 divided by 1. So in this case, you get the cosine of 90 degrees to be equal to 0. What about the tangent of 90 degrees? So you can see that the tangent of 90 degrees will be 1 for PM and 0 for OM. So this is undefined. So the tangent of 90 degrees is not defined, so just say it is undefined. So those are the ratios which we call the standard ratios of 30 degrees, 60 degrees, 45, 0 degrees, and 90 degrees. So your duty is for you to be able to know these ratios and use them. So you see later how we are going to use these ratios. Is there any questions so far? All right, so if there is no question,
Recording
then
stopped.
we can stop here for today. We'll meet again next week on Monday. So have a wonderful weekend. So please remind your colleagues that now they can join, at least I can accommodate 200 on Google Meet and on Zoom. So please ask them to join next time. All right, so we'll meet on Monday.